Maritime Made on Eastlink is presented by Nova Scotia Business Inc., helping companies large and small grow through export.
When Bill Gates recognizes your company as a game changer, people take notice. The innovation at Carbon Cure Technologies in Dartmouth, Nova Scotia, has people taking notice all around the world.
Carbon Cure is looking to provide sustainable technologies for the concrete industry, largely centered around beneficially using carbon dioxide, which in many contexts is a waste product, but it's something we can recycle back into concrete to make it even better. The big problem we're trying to solve is that concrete is the world's most widely used material after water. And so you're talking about something that's produced locally. It's got a lot of advantages. It's produced around the world. But when you make cement, for each ton of cement you make, you release almost a ton of carbon dioxide. So in order to meet the needs of global infrastructure, and concrete is always going to be a very big part of that, we need to be more sustainable in our practices. We have to make concrete with a lower carbon footprint.
Concrete is essential for the infrastructure we use in our day-to-day lives. But it's a high-polluting product. Carbon Cure's technology injects captured carbon into concrete. The carbon increases the strength of concrete, which means less cement is needed to make a structure just as strong. By reducing the amount of cement needed, less CO2 is emitted during the manufacturing process. The end product is low-emissions concrete. Carbon Cure's technology is installed at over 300 concrete manufacturing plants all over the world. This command center keeps the head office in touch with each system. A real-time data stream feeds the command center with diagnostics and other information that report on each Carbon Cure system around the world. The Research and Development Lab performs ongoing work, looking for ways to improve performance and develop new technologies. This researcher is preparing to test customer samples. This test is called cement screening. Samples are prepared, dried, and crushed, then collected in a vial. A tiny amount of material is placed on a slide, and the sample is ready for further analysis. These samples are looking at 8 different concrete mixes over 28 days and measuring the compressive strength at various intervals. Here, a sample is tested to determine how much force is required for it to fail. The applied force and the sample resistance is measured.
Well, what we provide a concrete producer is a carbon dioxide utilization technology. It's got a few main components, but it starts with a supply of CO2. You can capture that and sell it. And so one of the customers now is our concrete producing network. With this CO2 supply, they're able to inject the CO2 into the concrete. Much like if you've ever discharged a fire extinguisher, you'll see a mixture of solid flakes of CO2 and some gas. That goes into the concrete, and what happens is it actually makes the concrete stronger. So a concrete producer doesn't need stronger concrete, they need strong enough concrete. And so if you've given them extra strength to play with, they're able to leverage that into making a more efficient use of the cement, which is what provides the strength in the concrete. More efficient cement use means you can use less of it. Less cement used means less CO2 emissions associated with the concrete itself.
The assembly of each Carbon Cure system is done on-site in their production facility. The system is made up of 2 cases or enclosures, a controller and valve enclosure. This component is the valve enclosure. It manages the flow of CO2 into the concrete mix and would be located where the concrete producer is loading trucks. This box is the control enclosure and would be located in the batching office of the concrete plants. The person controlling the concrete production would have access to this controller and would program how much CO2 needs to be injected into the concrete mixing trucks for each job. To begin assembling the controller, Programmable logic components are mounted to the back plate. Then, each component is wired. The red and blue wires are low voltage, and the black and white wires are higher voltage. The back plate is ready to be mounted inside the control enclosure. The plate is secured in place. On the door, there is a power switch, alarm buzzer, an emergency stop, and the customer interface screen. These are wired to the system on the back plate. After the screws are tightened, the antenna is installed. This allows the unit to share data with the command center. The power cable is threaded into the enclosure and connected. A strain relief holds it in place. The parts for the valve enclosure are threaded and ready for assembly. Using a vise and wrenches, each part is secured to the next, creating the pathway for the CO2 to travel through. The parts include a temperature control and a check valve which ensures the gas can't flow backwards. The orifice is the last fitting that goes on the internal pipes. Then, the liquid and gas valves are attached. The entire valve assembly is mounted to the back plate and then placed inside the valve enclosure. The communication cable is installed. This cable allows the valve enclosure to communicate with the control enclosure. Corner bolts are installed, and the assembly is complete. Each system is calibrated and undergoes a final quality check. Here in a test, you can see how liquid gas CO2 turns into a solid as it is pumped out. It's called snow. At a concrete plant, this is what would be pumped directly into mixer trucks, adding strength to the mix. CarbonCure systems are shipped all over the world.
This company got started inspired by the impacts that the built environment is having on the climate, specifically the carbon being discharged into the atmosphere is leading to climate change. And so we thought there must be a role for the built environment to help mitigate climate change. What we're doing with the CarbonCure ReadyMix technology is for each ton of CO2 that's injected, we can realize a benefit of about 40 tons of avoided CO2. So that means every single truck that goes out using our technology represents a carbon reduction. We're on a mission to make a 500 megaton per year carbon impact.